who first shared their stories in caves, connected art, nature, and science, led us toward new horizons. Who thought to capture motion, spark an engine to life, turn television into a playground. Every day, you create the playful, the functional, and the unexpected. You break down walls and take us to astonishing places. Tell stories, leap borders, and create beauty for tomorrow. Because at Unity, we believe the world is a better place with more creators in it, where everyone has a chance to shape the world.
Good afternoon, everybody, and welcome to our South APAC 2022 webinar series. And we're joined by a pretty big crowd today, representing a lot of parts of APAC. And as you can see from the welcome languages on our screen, it encapsulates quite a diverse audience all the way from Greater India, Southeast Asia to Australia, New Zealand, and the Pacific. And if you'd like to tell us where you're from now, please go to the chat window and just let us know which country you're joining us from today. Apart from what I just asked to drop your country in the chat window, great, we've got some Nepal, we've got Philippines, India, Cambodia, quite a lot there, New Zealand. Please don't use the chat during the webinar to ask questions. If you have any particular questions for the panelists, please put them in the Q&A box. If you're joining us on Zoom, if you're joining us on another streaming service, you may use the chat option in there and we will bring those into the main room. Today's webinar is approximately 75 minutes. And please don't use the raise hand function as we don't use it in this webinar today. Unity real-time 3D technology is being used in many industries across all sorts of sectors, from architecture, engineering and construction, in the design and construction phase of buildings. It's being used in the automotive, transport and manufacturing industry, in simulation. It's been used in education, film and animation, amongst many, many others. So becoming a Unity certified developer, all the way from beginner level to a user to an instructor, gives a Unity user many career opportunities across many different sectors. So we encourage you to take a look at the certification program today. There's a link there for you to take a look at, and you can start your journey online. Few recent developments in the Unity ecosystem. In the last 3 months, we announced 2 major acquisitions. One is Weta Digital, and Weta Digital is part of, as a New Zealand special effects company, behind lots of movies that you would be familiar with, from Lord of the Rings to the new Batman movie, new Doctor Strange movie coming up. They're a multi-award-winning, Academy Award-winning special effects company who are now part of the Unity family. And just recently, we also acquired Ziva Dynamics, who create virtual humans using biomechanical simulation running real-time in Unity. Please stay through to the end of the webinar today. We're giving away a Unity swag pack for one lucky draw for attendees who have registered today. If you're joining us on YouTube or any other social media stream and you haven't registered to qualify for this prize pack, please use the QR code and register. At the end of the webinar, we will give a survey link, and in that survey link, you'll be able to opt in to be in the draw for this prize pack. There's the QR code there now. If you've missed it, it's going to be on the next screen as well for a moment. And here are some of our previous winners from recent topics who are sporting and showing off their Unity swag. We'll also give away an extra prize pack today for the best question, and we'll actually announce that winner in the session. The swag pack lucky draw that will be drawn about 30 minutes after the webinar, and we will contact the winner by email. Today's session is going to be conducted by Hector. Hey, Hector, how are you doing?
Hi, Andy. All good. How are you?
Excellent, excellent. Bit of rain here. I'm looking forward to be back in Singapore shortly. This is part of a 3-part series. Today's webinar content was pre-recorded last night. We've done that to optimize quality. We have an audience from a very big region with different bandwidths. So in our experience over the last 12 months, this makes for a better experience for you. But Hector is with us live today. He'll be answering Q&A and answering questions throughout the presentation. So without any further ado, let's get into today's content. Thank you, Hector.
Hello, everyone. Welcome. My name is Hector. I am a field engineer at Unity based in Singapore, and I'll be guiding you on today's webinar, Building 2D Games with Unity. This is the first part of a series, and today we will be covering the basics. All right. For today's session, we will explore Unity's useful 2D features, such as the ability to import sprite sheets, create tile maps, and implement a pixel-perfect camera. Then we're going to go over how to create animations using sprites and how to use Mechanim to switch between them. Finally, I want to point you to some resources we have online for you to download and explore at your own time. We prepared a video to show you some of the 2D games made with Unity. Let's have a look. Unity is not just for 3D games. Unity is a complete platform for building beautiful and engaging 3D and 2D games. In fact, hundreds of thousands of creators rely on Unity to get the latest and best tools for developing, launching, and earning revenue with 2D games. Also, regardless of your background, whether you are an artist, a game designer, a programmer, you can take part in the creation of a project such as this. We know there is a lot of hard work put into making games like the ones you see here. Personally, I grew up playing 2D games. So even after 3D became the new standard, games made in 2D still have a special significance to me. And I'm not just talking about the pixelated retro style games, which is a visual style I really like. But if you think about it, current generation computers and consoles have so much more RAM available that you can load beautiful high-resolution textures to make your games even more unique. I think it's amazing to see so many different art styles in games made with Unity. And this means that if you are a traditional artist with zero experience working with 3D digital content creation tools, you can still build amazing video games and bring your vision to life. Right, I hope you liked that video. Let's get right on it. Okay, so what are sprites? Well, graphic objects in 2D are known as sprites. Sprites are essentially just standard textures, but there are special techniques for combining and managing sprite textures for efficiency and convenience during development. Unity provides a sprite editor to let you extract sprite graphics from one larger image. This allows you to edit a number of component images with one single texture in your image editor. You could use this, for example, to keep the arms and legs and body of a character as separate elements in one single image. These are some of the tools and assets available for you to deal with sprites in Unity. Placeholder sprites, which allows you to quickly generate simple shaped sprites to start prototyping your ideas. Sprite Editor. As we've seen in the previous slide, the Sprite Editor lets you extract individual sprite graphics from a larger image, as well as define many useful properties such as pivot point, custom outlines, physics shape, secondary textures, and there is even a skinning editor which we will explore in upcoming webinars. Then we have the Sprite Renderer. Sprites are rendered with the Sprite Renderer component, rather than the mesh renderer used for 3D objects. The Sprite Renderer controls how it visually appears in a scene. And finally, the Sprite Atlas. A Sprite Atlas is an asset that consolidates several textures into one single combined texture, improving workflows and runtime performance. Let's have a look at how to create placeholder sprites. You can create temporary placeholder 2D graphics to use as sprites. You can use this in your project during the development and then replace them with the graphics you want to use. You can find them in the Assets menu following this path right here. Assets, create 2D, sprites, and then select the placeholder sprite you want to generate. See the list right here? And this is what they look like. We have some primitive shapes like square, circle, capsule, and so on. When you select one of these, what Unity does is it creates a PNG image in your project and sets the correct import settings to be used in your game as a texture type sprite. These images are made out of white pixels on transparent background. And this is useful so that when they are rendered as sprites, we can specify a color in the sprite renderer component, and that way get multiple variants from the same image. As a programmer, using placeholder sprites is useful to start prototyping when you are waiting for graphic assets to be ready and you want to focus exclusively on game mechanics. Let's have a look at them inside Unity. Okay, we're going to start with a new project. I'm going to select the 2D core template, give it a name. We're going to go over the placeholder sprites, so call it something like that, placeholder sprites, and create a project. The Unity Hub will create a new project for me and open Unity. Right. So we are now in the new project, placeholder sprites. So we're going to start by creating placeholder sprites. I'm going to right click in the project window and select create 2D sprites. And here are the options I can select from. I'm going to start by creating a square, click on it. I can give it a name. Let's just call it square. And there it is. My new PNG image is added automatically. If you look at the import settings, it's automatically set to 2D sprite. And it has a pixels per unit 256. This is a 256 by 256 PNG with white pixels. I can start using it right away. I can drag and drop it into the scene. These are one world unit, and I can stretch it and move it around, place it as a ground level, for example, and change properties such as the color. I can choose a different color. For example, I can make it green, like the grass. Then if we look at the game view, the camera is rendering a background as blue, so that could pass as a sky. And now we have like a small little level. Then I can bring some elements into this. For example, I can reuse the same square and maybe add a box crate here. And that's it. How about if I want to bring in like a ball? So in order to do that, I create a new one. I go to create 2D sprites and I can bring a circle. So when I bring a circle, I can name it and I can drop it in my scene, like so. So I could add colliders to these boxes. I can add a circle collider to this sphere, and add a rigid body. And if I enter play mode, I already can see that my simple environment with my character is already interactive, and I can play and start prototyping ideas. So this is all good. Actually, the boxes could also have rigid bodies so that they are affected by forces, and I can possibly stack them, something like this, duplicate and put one more on top like so, and try again, enter play mode, and there we go. The idea is that we can start prototyping ideas without having any graphics. So when in the future I receive art from my artist, I can bring those in I have a basketball PNG and a crate PNG. So I can bring these two over to my project. Make sure these are set to Sprite 2D. They should be the pixels per unit should match the resolution of the image. So this is like 144. Let's do that, 144, and apply. And the crate is actually 32 by 32. So let's make sure that the pixels per unit is 32 so that it will become one world unit. And that's it. Now what I can do to replace these graphics, the placeholders, with the actual art I have is go back to the squares and select them. Or I can select one of the squares and show you here. The sprite renderer component has the square placeholder defined. So I can look for my assets here. And in this particular case, I can choose a crate. And when I choose a crate, you see it replaces the image of my placeholder with the actual art that I received. I can multiple select these two sprites and maybe drag and drop the reference of the sprite so to make it faster. And finally, the same thing for the basketball. And that's it. That's how you can use placeholder assets. And that is placeholder sprites. Very much like the mesh renderer for rendering 3D models, the sprite renderer specializes in rendering 2D images. After we imported our sprites, we can define which sprite to render in the sprite property. You can define the vertex color of the sprite by selecting a color from the color picker in the inspector. There are different types of draw modes. Each mode specifies how the sprites scale when its dimensions change. You can see right here we have a default option, it's simple, which scales the entire sprite when we change dimensions. In this case, you can see that the sprite gets distorted by being stretched horizontally. It's this one, the very first one right here. Next is sliced. You can see that it only stretches the center of the sprite and will preserve the dimensions of the borders of the sprite, and the corners remain nice and round. That's the third one, sorry. This one right here. And finally is the tile draw mode, which is the one in the middle. This causes the middle of the 9 slice sprite to tile instead of scale when its dimensions changed. Sprite masks are used to either hide or reveal parts of a sprite. In the example here, I added a sprite mask on the same game object that is rendering my character sprite. And this works nicely in case you want to use a gradient mask and play with the alpha cutoff value to create some sort of dissolve effect. However, you can create a sprite object separate from the game objects you want to mask. And play with scale and position to hide and reveal any areas of your sprite. Sprite masking is a very powerful component which can be used in many creative ways. There's also more advanced ways of using masks that affect only groups, only by using a sorting group object or defining a custom range so that the mask will only affect sprites being rendered within the given range. You can set the sorting layer of the sprite, which controls its priority during rendering. You can select an existing sorting layer from the drop-down menu or create a new sorting layer. Also, you can manage the sorting layers by going to the project settings and selecting the Tags and Layers option. Here you can add, remove, rename, or reorder your sorting layers. Unity will render sprites grouped by sorting layer in the order defined here, and it will use the property Order in Layer to define priority for sprites in the same sorting layer. And that is the sprite renderer component. Now let's have a look at the sprite editor. This tool allows you to define how to import your source textures. The imported images can be single sprites, like the one shown here, or can be what it's called a sprite sheet, which is an image containing multiple smaller images. In a game where many small textures are used frequently, it's often more efficient to store the textures in a sprite sheet, which then is treated as a single texture by the graphics card. This reduces both the disk input-output overhead and the overhead of a context switch, which leads to better performance and allows your games to run more efficiently. The best way to explain how this works is to show you in the Unity editor. So let's have a look. So now let's have a look at how to use the sprite editor. First, I'm going to bring some images I have into the project. So I have this apple, for example, drag and drop it into the project window. And when I click on it, you can see that it automatically identified it as a sprite. So that's good. I don't need to redefine the texture type. And then I have access to this button right here, Sprite Editor. The Sprite Editor, when I click on that, this is what it looks like. It's another editor window. You can dock it any way you want. But we have some things that we can do here with this sprite. You see in the center of the apple right here, we have this blue circle that is the pivot point. So we can move it around and see what that does. In this little inspector on the corner, you can see that it's changing values. So I can have a custom pivot point, or there's some shortcuts, such as the usual, like top left, top center, and so on. If I click apply, now I can use my sprite in the scene, drag and drop it. And the pivot point is helpful because it's a center of rotation and it's a center of scale. So if I move that pivot point to one of the corners, it's going to scale and rotate around that corner. And one more thing that you may notice is that the apple is being rendered by a few different triangles right here. I like to have the shading mode set to shaded and wireframe. So by default it's shaded, but you can see wireframe. I like to have this combination, shaded wireframe, where you can see how this is being drawn. But also, if you select the original image and go to the mesh type, you can select full rect. And what that does, it will render the sprite with two triangles. If I click apply and you look at the scene view, now my apple is being rendered with two triangles. So this might look simpler, but what's happening in this particular image is that there's a lot of transparent pixels. The problem with this, if I have multiple images that are seemingly close to each other but not really overlapping, this may cause some performance issues if we have hundreds of thousands or thousands of sprites. So there's one more way to see another shading mode, which is called overdraw, which will show you which areas of the screen are being drawn over and over multiple times. And you want to try to minimize overlapping and overdraw to improve performance in 2D games. So the default setting of tight mesh is actually the preferable one. So you can click apply and see how the apple now changes to like a shape that mostly follows the area where the pixels are. And if I go back to overdraw, there's very little overlap now. So this is more efficient. All right. So next up is multiple sprites. So I can go back to my assets that I have prepared here, and I have a multiple PNG. I'm going to drag and drop into my project window in Unity. And by selecting it in the project, you can see in the inspector that is correctly set again to sprite 2D type, texture type. And the key difference from the apple that we brought earlier is that the sprite mode is multiple as opposed to single. When I make this change, I need to click apply. And now when I open the sprite editor for this, I am able to slice multiple sprites from here. So I can zoom in and, for example, draw a box around this sword, or around this looks like a diamond or a gem, and hit apply. Once I do that, you see below in the project window, those two sprites that I selected, box selected, are made available in the project window. I can close the sprite editor and start using my sprites. And this is all great, but there is a better way of doing this, which is to automate the slicing process. So I can go back to sprite editor, and there's this slice button right here. and there's an automatic option. If I click on that, Unity will find, the sprite editor will find all the islands of pixels surrounded by transparent pixels and draw a box around them. By doing so, I can then click apply once, and you see my project window, all the sprites that were identified and sliced are available, so I can just start using them. I can drag and drop from here everything I want and start using my sprites. And that is Sprite Editor. Let's have a look at the Sprite Atlas asset. The Sprite Atlas is an asset that allows you to aggregate multiple textures into one big texture containing sprites from many different sources. Those sources can be not only single sprite textures, but also multiple sprite textures. And it even supports folders as sources, in which you could have many different files. There's benefits to using a Sprite Atlas. Unity normally issues a draw call for each texture in the scene. So, in a game with many textures, multiple draw calls can become resource intensive and can negatively impact the performance of your game. By combining sprites into a Sprite Atlas texture, Unity can issue a single draw call instead of multiple draw calls to access packed textures all at once at a smaller performance overhead. Let's have a look at how to use a Sprite Atlas in the editor. Let's have a look at how this works. So imagine I have these assets that I want to bring into my game. I have a texture of a crate, a single sprite. I have a sprite sheet full of items that we used before. And I have a folder. This folder is full of PNGs and that I also want to bring into my project. So let's go ahead and do that. I can select everything and drag and drop it into the project window. That will import them into Unity. And from here I can start using. I'm going to have a look at the crate one. If I select it and look at the inspector, the texture type is already set correctly to Sprite 2D and the sprite mode is correctly set to single. So I can start using it right away. I can drag and drop it into my scene. Next thing is the multiple sprites tile sprite sheet. I need to make sure that it's set to multiple sprite mode. Then opening the sprite editor, I can slice it automatically and click apply. That makes all the sprites individually sliced available, and then I can just drag and drop them into my scene and start using them. This is all good. And finally, the individual sprites from my folder. For example, I can bring this, a baseball, basketball, and this is all good. So why do we need a Sprite Atlas then? The idea is that we can combine all these sources into one texture to optimize performance. And right now we have very little textures and the performance might not be an issue, but I can show you how this impacts performance at a low scale, and then you can see how it will how improve situations in where you have like hundreds or thousands of images. So if you go to this statistics panel, you can see here that there's this thing called set pass. Set pass is set to 5 right now. And why is it set to 5? We can investigate by going into Window, Analysis, and then there's a tool called Frame Debugger. The Frame Debugger allows me to take a snapshot of one of the frames that Unity is rendering, and I have this slider to go back and forth and see what's going on. And you can see that it first is rendering the baseball, which is an individual PNG file, then the crate, which is an individual PNG file, then another, the basketball is also an individual file, and then see what happens. In one pass, all these 3 items are rendered at once, and that's great because those come from the sprite sheet. So Unity is smart to batch them and render them in one go for performance. So what we can do is use a Sprite Atlas to combine all these different sources into one mega sprite sheet to be able to render everything in one go. And it's very easy to do, so I can show you how to do it. Let's close this for a second again. To do that, we go into the project window, right click, create 2D and Sprite Atlas. Once I click on that, it's going to create an asset in my project window. I can give it a name, call it something like all graphics. And with the Sprite Atlas selected, I can look at it in the inspector on the right. And here are all the properties for my atlas. But the thing that is most important to me is this one, objects for packing. I can add things to this list and the atlas will combine them. So it works as simple as drag and drop. So I can go to my crate and click and drag into the objects for packing and it's added to the list. The next is the multiple spreadsheet. I can click and drag it to objects for packing and it's another item. And most impressive feature is I can drag this folder and set it as a source and it's added to the list. So now I have individual PNG file, a spreadsheet with multiple sprites that have been sliced, and a folder which is full of other PNG files. And by doing that, when we enter play mode, you can see what it does. It creates an atlas combining all the sources that I defined. The individual crate, all the items from the spreadsheet, and all the individual balls that we have as separate PNG files, they were all combined into one. And if you look at the statistics, there's only one pass, one draw call now. So this is optimized. We can also bring up the frame debugger again, click enable, and then confirm that they are all now rendered in one go. All the draw calls are batched. So you can imagine in a game where you have hundreds or thousands of sprites, if you use Sprite Atlas, you will improve performance significantly. And that is Sprite Atlas. Unity's tile map system makes it easy to create grid-based 2D levels and worlds. Without any coding, you can draw tiles onto a tile map. It's a flexible and powerful tool with components to help you render large tile maps efficiently and help you generate optimized 2D colliders for your game characters to be able to walk on and interact with the levels you create. We're going to look at how we can use a sprite sheet to generate tile assets, and then how to import these tiles as a palette for us to use to easily place and paint tiles in our scene. Let's jump over to the Unity editor. All right, next tab is tile map. So we are going to start here with our project. I have my character sitting in the air with a background and nothing else there. I can show you what happens if I enter play mode. My character falls because there's nothing to stand on. So we're going to fix that. We're going to put some platforms by drawing them with by drawing a tile map on it. So to start, we need to bring in the spreadsheets that I want to use. So let's go look for our images. And I have a bunch of different spreadsheets I have here. I want to use this one called grass platform tiles. I just drag and drop it into my scene, into my project window, sorry. And then I need to make sure that this is imported correctly. It's set to default, which is not what I want. I need to be Sprite 2D so that I get access to the sprite editor. So when I click on the sprite editor, I'm going to apply the changes. I need to be able to slice this. Oh, the slice functionality is not enabled because I forgot to set it to multiple. Let's do that. It's going to be multiple. Now I go into the sprite editor, and now the slice functionality is available for me to choose. I'm going to choose by grid cell size. I know these tiles are 64 by 64, so that's what I'm going to use. And click apply. You see now that all the tiles become available to use. Next up is I need to create a tile map. In order to do so, I can go to the hierarchy and click on this plus sign and choose 2D object, tile map, and choose rectangular. Once I do that, you will notice that in the scene view there's a grid that shows up, rectangular grid, and a grid component grid object was added, and a child tile map game object was added. The tile map is like a layer. So I'm going to use this tile map to lay platforms. So I'm going to rename this to platforms. You can see that in this tile map component, I have in this tile map object, I have a tile map component and a tile map renderer. And in the parent, the grid object, I have a grid component. The grid component has some properties that are interesting, like for example, cell size. I can change the cell size to define like irregular size rectangular shapes. And I can also change the different types of layout, for example, hexagon or isometric. And by playing with the isometric and the vertical scale, for example, half, I can achieve like a grid that looks like a traditional like old school strategy games. But for now, let's go back to rectangle and set everything back to 1. So next step is I need to add I need to convert my sprites that I want to use into tiles. So the tiles are the things that I can use to paint on my grid, on my tile map. In order to do so, first I need to create a palette. And the palette is very much like a painter's palette where you place colors and then you sample them with your brush. So we need to create a palette to be able to create these tiles to sample. By having the grid selected, you notice that there's this option that says Open Tile Palette. Automatically shows up here in the scene view. I can click that and open the tile palette window. Actually, you can also bring it from window to the tile palette. And once I have this palette window, I can dock it next to my hierarchy. Maybe make the hierarchy a bit smaller so that we can see better. And I'm ready. So what does it say here? Let's have a look. It says create a new palette in the dropdown above. So it's prompting me to create a palette. Here's a dropdown. So I need to start by creating a palette. The palette window has no palettes created, so I need to create one to begin with. I'm going to call it something like platform palette and create. When I click create, it's asking me for a folder to store this palette. So to keep things nice and organized, I'm going to create one folder called palettes and select the folder. You can see that I created this folder in the project. And if I go inside, there's a file, a prefab. And this has all the information relative to this palette that I just created. But the palette is empty, there's no tiles inside. So I need to add tiles to be able to start using it to draw my tile map. Now you see that I have my platform palette selected. It says the instructions here in the center of the box say drag tile, sprite, or sprite texture assets here. So if I had already tiles created, I can drag them and put them here. But I can also create tiles automatically by dragging individual sprites into the palette, and it will prompt me to save as a tile. To speed up this process, I can just drag the entire multiple sprite sheet into my palette and drop it, and it's going to ask me for a folder to generate the tiles into. So very conveniently, I can just create a folder called platform tiles and select that folder. Unity will then go through all the different sprites and create one tile asset for each one of them. You can see the folder created there, and if I go inside, these are all the tile assets that were created of the different sprites. You can see in the inspector that there's some additional information. It's not just the sprite, but it's also a color and collider type. So that's why we need an intermediate type. And then you can see in the palette, all my tiles have been laid out nicely in the same layout that they were placed in the sprite editor. From this point onwards, what I can do is simply the same way that you would paint using a normal paint palette. Is like click on the tile that you want to use, and then move your mouse over to the scene view and start click and drag to draw. And I'm drawing with my tile. Oh, I'm noticing an issue here. My tile is not filling up the entire cell. So I know why that is happening. If you remember, when I imported my spreadsheet, I forgot to set the correct pixels per unit. If I go back to the sprite editor, I can confirm that the cells are 64 by 64. So let's add that value into the pixels per unit, 64. And when I hit apply, all my tiles take up 1 world unit, filling up the cell correctly. And the tile palette also updates automatically. And now I am able to like start sampling like a corner of this tile, sample this area, sample this bottom corner, the bottom of the platforms, the lower left corner and the left side, and maybe paint the inside. And this is how you can start painting tiles using tile maps. Alternatively, you can also do things like select the box in the palette and bring that selection into the scene and draw with that, which is a bit like, it may not work in all situations, but you can also just click and think of it as a stamp or a copy paste. And also you can click an empty cell to lose a selection. You can also select the erase tool and erase the tiles that you don't want. And there's this one I like, which is the move selection. Once you have laid out things on the scene, you can press press and hold Control key and drag a selection. And with the move tool selected, you can move your selection around. So it's very convenient. Especially like if you say, oh, these platforms, they need to be a bit more to the side once you lay them out to play with the level design. Oh, there's one more thing. I probably need to move this out of the way, maybe here. And maybe I'm going to bring this back a little bit higher up. This one a bit slightly closer. I don't really like that up there. I'm going to erase it. And this is how you can paint. But now what happens if I enter play mode? You can see that my character falls through the platforms because there's no collider on them. So we're going to fix that. We need to go back to the platform style map and add a new component. And there is a convenient component called tile map collider. And when I add that component, you can see what happens. All my tiles get a collider around them. And this is very convenient because all I did was add a component and now my entire tile map supports collision. And you see these lines is because I have the gizmos on. I can turn it off. But that's also something I want to address. Like I have colliders even on the tiles that are in the inside. And there's no need for that to happen. So luckily there is a way to optimize and combine these colliders that are adjacent to each other. So in order to do that, we go back to the tile map and right underneath the tile map collider, click add component. And we can add this component called composite collider 2D. And by doing that, I need to select one option in the original tile map collider 2D called use by composite, which says it will define whether the collider can be used by an attached composite collider or not. So if I click on that, look at the scene view. Now all my box colliders around the tiles that are adjacent to each other, they become combined into a simpler shape. And that helps performance a lot. Because imagine you can have hundreds of these tiles. And by the way, these colliders are calculated automatically. So if you're drawing new tiles or combining tiles, the collider shape now is around this composite area. You can always undo. And now if I enter play mode, my character falls to the the platforms fall to the ground. The reason for that, and this is something that you can you will find is the moment you add a composite collider 2D, it comes along with it a rigid body component, and the rigid body component allows the collider to be affected by forces. The default body type is set to dynamic, so we need to set it to static so that the platforms don't fall. So now when I enter play mode, the platforms stay put. They have collision, simplified collision, and now everything works as expected and is optimized. There's one more thing I want to show you, which is I can bring in this other sprite sheet for painting details, some props. So I'm going to drag this into the scene, send this back out. Make sure that the import settings for this new texture are correct. So they need to be, again, 2D, maybe 64 like they were the other one. Make sure there is multiple. Go into the sprite editor. And now I need to slice them. Please take note, the automatic slice tool will draw these boxes around the trees, which is good for situations where I want to use this as a standalone sprites. But in the case that I want to use them in a tile map, it's not ideal. So I would like to slice them in the same dimensions that I sliced the grass platforms. By doing so, and hitting apply, the slice sprites become available here, but the important thing is I can use them in the palette. So I can drag and drop the same way that I did before and add to my palette. Again, it's asking me for a folder to create the tiles. I can create a new folder, prop tiles. Select the folder, and that's the same process as before. It will create a tile asset and make them available in the tile palette for me to use. And I could do something like paint on this layer, but if I paint where my platforms are, it's going to erase my platforms. So I don't want that to happen. What I instead want to do is create another layer or another tile map. So I can go back to my hierarchy. Yeah, like that. So I created a second tile map. I'm going to call this maybe background props. And notice I have a sprite renderer. And once I have a second tile map, it's like having a second layer in Photoshop. I need to select in the tile palette the active tile map I want to draw onto. So right now I'm drawing on the platforms. If I select background now, I can click on this and start drawing, and it will draw on a different layer without affecting the original platforms that I had there. So this way I can lay out some elements. I can box select these trees and add some trees to my environment. And these are all just cosmetic. They don't have a collision. They don't collide with the character because this separate tile map has no tile map collider. Then there's no collision information generator for that. And if I enter play mode, now I can see my level with the original platforms plus the new props that I added. But there's one more thing. If you notice, these new layers are being rendered on top of the character, and that's not what I wanted. I want them to be in the background. So in order to do that, you will find that the tile map renderer, similar to the sprite renderer, has a sorting layer that we can choose, or you can define the ordering layer. So let's have a look at our character right here. She's being rendered behind the rock, right? So if I go back to my background layer and maybe set this to a -1, not change the ordering layer, but change this to background. And that makes it so that it will follow the order of the sorting layers defined in project settings. And that says that it was going to render the background layer first. And that's how I fix my problem. Now I have a map that I painted. I added a collider so that my character can walk around. I optimized the colliders by adding a composite collider. And then I created a second tile map with, I started painting some more details by bringing a second sprite sheet and adding more tiles to my palette. By the way, you could have this set on a different palette, or you can add them to the same palette. It's your choice. Just to make sure that when you are drawing on the right layer. For that, there's also this very helpful focus thing that you can do so that it will highlight the layer that you are on if you are ever confused on which layer you are working on at any given time. And that is tile maps. By the way, there is also, you can extend the type tile and create like animated tiles, smart tiles that allow you to just paint on the scene, and the tiles will automatically adjust to reflect the correct edges. And that's something I can show you in the next project. Right, now we can look at some rule tiles. What I have here in the palette is like seemingly single sprites, right? But see what happens if I select, for example, this one, and I start painting on the scene. It's actually not using the same sprite, but it knows what are the neighbor tiles and adapts itself to allow me to paint a level. So I don't have to worry about selecting the correct corner tiles or anything like that. All that information is calculated by itself by looking at the neighbor tiles, and then it will pick up the different variants. So if we select the tile, we can see how this works. So this is laid out as a rule tile, which is a specialized class from tile. And here are all the rules, like depending on the neighboring tiles, this is the sprite I will select. Another example is this one right here, which is water. So if I paint with this tile, I can generate like water. And if I'm painting in the same tile map, I'm going to be erasing the bricks one. So I'm actually like pushing through and making like a river. This is very fun. And also we have this one right here, which is pipes. So I can easily paint pipes. This one is not meant to like draw a volume, but instead like we can build a platformer, for example, like so. These are also some of the other custom tiles that we can draw. I'm just painting, and because of the rules, it knows what to use. And we can achieve some very interesting results. And finally, there's this one that is called, it's also a rule tile, but one of the rules that it defines is random output. And then you can set a set of sprites. And as I'm painting with this particular tile selected, it will randomly pick sprites from that list and place them on the surface. So these are the different types of rules that you can define to make your tiles smarter, therefore easier to build levels with. That is tile maps. By the way, not only the square grids that we worked on are possible. The tile map system allows you to select different types. For example, here I have one example of an hexagonal grid, which is very popular in strategy games. And also we have an example of isometric tile maps. We rely on other techniques that we haven't covered here, but the ability to render multiple sprites in a group and then control the depth based on different axes in order to render the elements correctly behind or in front of isometric objects. Next up is the Pixel Perfect camera. This component ensures your pixel art remains crisp and clear at different resolutions and stable in motion. So let's have a look in the Unity editor. Pixel Perfect camera. So right here I have a sample scene that can be imported from the 2D sprite package in the package manager, and it's showcasing what the pixel perfect camera looks like. I have the component attached to the main camera, and it's set to the pixels per unit setting is set to 16, which is the resolution these assets have been prepared for. And you can see that the game is running, it's interactive, so I can move around. And you can see how the camera, the follow camera, is actually snapping to the pixels. So that's because we have the pixel snapping value set on. If I remove that, then we have sub-pixel precision for the render frame. That might be desired or not. So this is an option that you can select for your games. Additionally, you can control the way that we render the pixels. So if I have a pixel perfect sprite and I rotate it 45 degrees, you see how it smoothly rotates because I'm rendering my pixel graphics to a 4K frame buffer. However, if I didn't want this to be the outcome for my pixel game and I want the rotations to remain at the target resolution, what I can do in the pixel perfect camera is set upscale render texture. By doing so, if I rotate my pixel graphics, now you can tell the difference. They remain in the target resolution. This might be the visual look you're going for. So feel free to explore and see what works for you. Another thing that you can do is define a reference resolution to be, for example, that of an old console or maybe very old retro system, and make sure that your pixels match correctly. However, if you wanted to support also newer modern displays that are widescreen, you can make this selection of uncropping the frame horizontally, for example, and then support widescreen on a retro style game. And the same thing for if you want, you can keep the letterbox for the vertical in case maybe you can use that space for some user interface. Or if you wanted to also expand it vertically, you can do that as well. However, if you wanted to preserve the aspect ratio of your original game, you can select crop frame, and there's this option called stretch fill, which will match whatever is the closest height or width to your aspect ratio of the display that you're currently running on. And you can just steal this space on the sides to render some additional graphics. And that's Pixel Perfect Camera. There are many different ways to animate sprites. Let's have a look at how we can use a tile sheet to animate frame by frame. Okay, for animations, there are different ways of animating sprites. Let's start by looking for one of these images that I have here. I have my LN sprite sheet or sequence of images. It's not a sprite sheet. And I can drag it and drop it into the scene view. So this brings one of the frames that I have for this animations sequence of images. So the way I can animate this character is by, let's change order here so that we can see it at the same time. So if I go to the sprite renderer and go to the sprite property, I can select another sprite. And this is how you can see the character moving, right? So this is what I want to do with animation. I can change the sprite of the sprite renderer component frame at a time over time to achieve the effect of animation. And that's how animation frame by frame is done in Unity. I could create an animation component and keyframe every frame to change the sprite property of my sprite renderer. But that is very time consuming. So there is a better way of doing this. The idea is to select all these elements and drag them and drop them here. By selecting all of them, Unity is smart enough to detect that you're trying to do a sequence of images, and then it will ask you to create an animation file. So I'm going to go to my folder that I want, and I'm going to call this idling, LN idling animation. And what that does, if I enter play mode, it already created an animation for me. I just selected all the frames and drag and drop into the scene. What it's actually doing behind the scenes is adding my sprite renderer. You can see here how the frames are changing over time. It created an animator component, and the animator component, if I double click on it, it will open the animator. It created automatically a state machine with my first state called Ellen idling, which is the animation, the animation file that I created. And that's all I need. Now I have animation. I can keep adding more states for my character. If I go back to the scene, then I have in this other folder a run animation. So if I go through the frames, I can preview what it looks like. If I wanted to create an animation, I can do the same thing. I can select all the frames that are interested in creating, and I could drag them somewhere else, but that will create a separate state machine. So what I want to do instead is like to combine them. In order to do so, I can drop them on top of the original game object that I created. And when I do that, the same thing is asking me for another animation name. I'm gonna call this Ellen running. That automatically created a second state in the same animator. So if I go back here, I can see my second state is here. So now what I can do is I can create a transition between these two states, one this way and one this way, and I can create a parameter called is running to know whether if I should blend to the running animation, the running state, or back to idle. And in this transition, by selecting the arrow in between the two states, on the right side, I can select the condition. The condition is going to be the running is true. And on the going back transition, I'm going to add another condition where is running is set to false. And by doing that, I can enter play mode. Have a look at what this looks like. It's playing the idle animation, but when I select the is running component, my character changes to the other state. And if I unselect it, it's going to go back to idling. So this state changing from the animator can be controlled by scripting and based on your simulation or your character controller. And this is how you add animation to sprites. And there's one more video I wanted to share with you. This project very well displays some of the use cases for the tools and workflows we've been learning during this series of webinars. Let's have a look. These games look amazing. So these are some of the resources that you can find for yourself. This one right here, the 2D game kit, I used some of these assets for today's presentation. This project is available for free in the asset store. You can download it and play. It's a full game, and there's a lot of components that you can use. So you can create your games without writing any code. You can draw levels in Unity using the Unity style map that we went over. You can use ready-made game mechanics as drag and drop components. visually editing with draggable gizmos to, for example, define where moving platforms are going or where enemies are and what is the range of the field of view, so that when they see the player character, they will chase after. And we also have a manual online that describes all of the components and how to use them. So this is a very good learning resource. And another project we have available as a sample is the Lost Crypt. This sample project showcased 2D tools including the PSD importer, skinning editor, particle effects, 2D lights, sprite shapes. This project uses URP and shaders created using the shader graph. And by the way, this is going to be covered in upcoming webinars. And we're going to be using this project in next webinars. Here's where you can find some of the resources and sample projects that I was showing you just now. I hope you learned something useful during this webinar. Thank you so much for tuning in, and I hope you have a great time building 2D games for the first time. If you have any questions, the team and I will be more than happy to help them answer. Thank you again, and we are open for questions.
Awesome. Thank you, Hector. Sarah has just posted in the chat window the survey form. Please fill out the survey form and opt in at the end if you would like to be in the draw for today's Unity swag pack. This will go to one person from a random draw about 30 minutes after the webinar completes today, and you need to be registered attendee to be in the draw for this. We'll go to the Q&A section now, and I think Hector, if you could have a look for a best question answer as well while we're in the middle of this, it would be great. And don't forget to join us next week for part 2 of this series and part 3 the following Friday. Is there any questions that you'd like to answer live, Ife or Hector, and particularly anything that may be of benefit to the whole audience? Thank you everyone for your questions today. We've had a few hundred questions in today's session. So while Hector's looking for a winner, if you have any other questions that haven't been answered, please feel free to do so in the Q&A box.
Yes, Andy, I'm here. So I'm going through the questions. The team is been very helpful answer questions live. We answer like hundreds of questions during the webinar, and there's still some open for answer. I found one question that I thought it was very interesting to answer live, and also I think I'm gonna pick that as the best question. Let me bring it up.
Sure, thank you. And the name of the person so I can contact them.
Yes. So the question is from Ibrahim Hanbal, and the question says, does Unity also allow for making games with a 2.5D style? And the answer is yes, definitely. So Unity is actually a 3D engine, and when you are rendering 2D games, we're using the same rendering technology to render, instead of a perspective camera, a orthographic camera. But behind the scenes, the 3D support for graphics is still there. So you can actually combine 3D assets and put them in your 2D games, and vice versa. So if you start using Unity in 2D, you can slowly transition into 3D and combine them and get like render tile maps using perspective cameras and get very interesting effects. So I'm gonna go and try to find more questions. Okay, so I have here one that says when and how to use different types of sprite renderer. So I think when we were showing the slides and there were different types of draw mode that allowed the tiles to be tiled, simple, or render them in a different way using the borders and edges that you can define on sprites. Those are usually meant for things that are going to be used as buttons or pieces of UI, where you want to keep the borders uniform in dimensions, but you want to stretch the contents, and then you can fit different sizes. Imagine a speech bubble, for example, on top of a character, showing different amounts of text when the character is speaking. So you can use the same sprite for the speech bubble. You don't have to have multiple sizes, one small, one big. And Unity will take care of rendering the and stretching the inside of the part of the speech bubble, and then keep the corners nice and round. So that's an example. Then, is there any difference in choosing to create a game via Visual Script or C#? Not necessarily. Visual scripting that we support in Unity using Vault plugin usually allows you to define the same logic that you would type in C# code. So wherever you're coming from typing code in C# and you want to learn that route, that is also good. But if you want to learn to write logic using visual scripting, that is also possible, and you should be able to achieve the same results. So the idea that we have visual scripting is to be more inviting for newcomers that have no experience writing code to get experience. But I learned originally to code, so I prefer to code as opposed to use visual scripting, but I see the benefits of using both. So it's up to you. So we give you options. All right. Let me see if there's any more questions. I'm gonna scan for a couple of minutes.
Don't worry, folks, if you have more questions, there's always next week's session. You can also get in touch with us on the events, SAPAC events email that you would have received when you registered. And also Hector may put his email address back up potentially, or in the chat window. So if we don't get everything answered today, we will get to you.
Okay, Andy, I'm still looking for some questions to answer live.
No problem.
There's some question that talks about HDRP or URP supports 2D games. Yes, definitely. So the tiles can be rendered using URP and HDRP, and the benefits of doing that is that you get access to post-processing effects that you can apply on top of your maps. And you can, for example, do fisheye lens on top of the 2D games, which gives it like a very nice effect, as if they were like rendered on a sphere, or anything you want. You can you've seen the examples that we show in the videos. If you have a vision, an art style that you want to convey, you should be able to achieve that using Unity. All right. Let me see if I find one more question to answer. All right. Asking, this is an artist question, I guess. What is the best software to make sprites and animations? Again, it depends on what you have experience with. If you're fine painting sprites, pixel art using Microsoft Paint on your computer, or you want to use Photoshop or any tool you want, as long as you can export them as a file image, like a PNG file, you can bring them into Unity and use them.
Okay, I think we're kind of running out of time there today, Hector. Thank you very much, everybody, for attending today. We hope you enjoyed part 1 of our making a 2D game series. Please join us for part 2 and part 3 in the coming weeks. Thank you very much for joining today. Please stay safe.